Graph the equation. Identify the vertex. Y equals 1/3 times x squared. We'll first identify the vertex, and we'll use the vertex and a few additional points to graph the equation. The x-coordinate of the vertex is equal to negative b over 2a, where b is the coefficient of the linear term and a is the coefficient of the squared term. Here, b is equal to 0 and a is 1/3, so x is negative 0 over 2 times 1/3, which is equal to 0. We can find the y-coordinate by substituting 0 for x into the equation. Y equals 1/3 times 0 squared, which is 0. And therefore, the vertex is the ordered pair 0, 0. In other words, the vertex is at the origin. Note that this is also where the graph crosses the x and y axis, and so this is also an x-intercept and a y-intercept. Let's find a few additional points. We'll create a table of values. When x is equal to negative 3, y is equal to 1/3 times negative 3 squared, and so y is equal to 3. When x is equal to 3, y is also equal to 3. And when x is equal to 1, y is equal to 1/3. Now we have a few points. We can use these points to graph the equation. On our coordinate plane, we'll let each dotted line represent 1 unit. So the maximum on each axis will be 6, and the minimum will be negative 6. We'll plot our vertex first. Our vertex is a point right on the origin. We'll also plot our additional points. We have the point negative 3, 3. So from the origin, we move left 3 units and up 3 units. We have the point 3, 3, so from the origin, we move right 3 and up 3 units. And we have the point 1, 1/3, so from the origin, we move right 1 and up 1/3. Note that the x-coordinate of the vertex, 0, tells us that x equals 0, or the y-axis, is our axis of symmetry. So we also know that we have the point negative 1, 1/3, which we can plot. And our graph will be symmetric about the y-axis. Now we draw a smooth curve through these points in order to graph the equation.